Okay, today we're looking at notes 11-5, add and subtract rationals with common denominators. So I want to remind you that if you have two fractions with common denominators already, 1/5 plus 2/5 equals 3/5. You add across the top, keep the bottom the same. So same goes with rationals. So if I've got common denominators, which I do, then I just add or subtract across the top. So 27 minus 5 gives me 22 over 11x, and then just like the previous two videos, you're going to simplify. So 22 over 11 can be simplified, and that gives me 2 over x. And then you definitely want to look at your original denominators and say what x cannot equal. So x cannot equal 0. So that's my final answer with restrictions. Okay, moving on, next problem. So common denominators here, I'm adding now, so just combine like terms. So you've got 4x and 2x, so that's going to give me 6x. And then I've got 1 and 4, which is going to give me 5. Over, keep the denominator the same, x minus 4, and I notice there's nothing that can be factored or cleaned up or simplified or reduced, so all I need to give is my restrictions now. X cannot equal positive 4. Okay, so moving right along, again here we still have common denominators of 4, so then it's addition, so I am going to combine my like terms. 3x plus x is going to give me 4x. Plus 8, there's nothing to combine with it. Keep the denominator the same, 4. But I do notice on this problem on top, I've got a GCF. So my GCF is 4. I need to factor it out, gives me x plus 2 over 4. And then what do you know? My 4's cancel, and I'm left with x plus 2. And there's actually no restrictions on this one because there's no x in the denominator. So that's nice. Okay, moving along here, I've got common denominators, and I'm subtracting, so nothing I can combine. X squared minus 4, can't combine it. Over, keep the denominator x plus 2. Okay, on top, yes, that is a difference of squares. X plus 2, x minus 2. Okay, over x plus 2. So of course your x plus 2's cancel, and that leaves me with x minus 2 for my answer, where x cannot equal, because the original denominator, it would be x cannot equal negative 2. So that's my answer on that one. Okay, moving along here, I have addition. So I can't combine those because one's an x squared and one's an x, but I'm going to put it in standard form, x squared plus 3x. However, I can combine the negative 8 and the positive 2 to give me negative 6 over x minus 2. So you probably imagine that this is probably factorable, but let's see. So numbers that multiply to negative 6 and add to 3, well, multiply to negative 6, add to 3. I cannot think of any. Hopefully at home you're saying you cannot think of any either. So I'm going to erase that equal sign, and you know what? Sometimes things just don't work out the way we want them to. So that is our answer, except we just need to give our restriction of x cannot equal 2. So, like it or not, sometimes things don't go down any further. Okay, next problem. We're going to put a star by this problem. We're going to put a star by this problem because that's a minus, and we have a binomial here for the second numerator. So make sure that that distributes all the way through. So I have here x minus negative x. So x minus negative x, minus a negative turns positive. So x plus x is going to give me 2x, and then negative 3 minus 7 is going to give me minus 10. So if doing it in your head is too much, rewrite this second fraction here, and then go ahead and combine like terms. Keep my denominator the same, okay? And then I do notice there's a GCF of 2 on top, which would leave me with x minus 5, and then x minus 5 on bottom. So yes, in this case, the x minus 5's cancel. So your final answer is 2, and your restriction for x is that x cannot equal positive 5. Okay, we're almost done. Can you believe it? Okay, so next problem here, common denominators. Don't you just love common denominators? We're subtracting n squared minus 64 over 2n plus 16. So on top, that's a difference of squares. So n plus 8, n minus 8. And then on bottom, hopefully you also notice there's a GCF, 2, n plus 8. Okay, my n plus 8's cancel. I'm left with n minus 8 over 2, where n cannot equal, it's easier if you look at it from the factored version. You could look at it here and set that equal to 0 and solve, but to me it's easier to see it here. N cannot equal negative 8. Okay, we are almost done. All right, last problem here. Again, we do have common denominators. Now that's a trinomial. We're going to have to factor it, but just not yet. So x squared minus 2x, we get x squared minus 2x. Can't combine those. They're not like terms. One's squared, one's not. Over 3x squared minus 7x plus 2, keeping the denominator the same. So I'm going to try, it may not work, but I'm going to try to factor both. I see there's a GCF of x on top, so that'd leave me with x minus 2. Over, let's try this. Let's do some guess and check fun here. So it's going to be 3x and x if it's going to work. And then numbers that multiply to 2, that's just 2 and 1. And since I notice that the O and the I have to add up to negative, and then the two numbers have to multiply to be positive, that must mean that they're both negative. And because I want it to add up to negative 7, I definitely want that 2 there and that 1 there, because negative 2 times negative 1 is positive 2, but negative 1x plus negative 6x gives me negative 7x. So that works, yay. All right, and then my x minus 2's cancel, and I'm left with x over 3x minus 1, and again, parentheses, either or, if you want them or not, doesn't matter to me. And then restrictions, easiest to see from this factored stage here are x cannot equal, let me make this a better fraction, 1/3. Also, x cannot equal 2. And we're done.